Understanding and installing the different parts of a wall frame is a very important part of being a successful construction craft laborer. Wall framing provides the vertical members of the house. In fact, the skeleton of a house is its frame. This means everything depends on how the framing is done. The frame consists of the floor, wall, ceiling, stairs, and roof. While framing, construction craft laborers should follow all building codes, construction drawings, and plans. As with all construction work, building quality homes is about practicing safety. The basic safety and organizational guidelines should be followed at all times on the job site when framing walls. Wear the right personal protective equipment, or PPE, on the job site. This includes hard hat, safety glasses, hearing protection, work gloves, work boots, and fall protection when working at or above 6 feet from the ground or other working surfaces. When constructing a wall frame, it is critical that a construction craft laborer know the parts that make up the wall. Wall frames, just like floor frames, have long spans of framing members that make up the support of the wall. Studs are the most common wall framing member. Studs span from floor to ceiling. Their function is to stabilize and bear weight from ceilings. The size of walls that you see in a home is determined by the height of the studs. They are typically made of 2x4 or 2x6 lumber. Stud layout will be one of the most important aspects of the wall frame layout. Determining which wall to start framing and the location and measurements of studs are critical to a well-built wall frame. Plates are found at the top and bottom of all wall frames. Plates act as a connector to the studs. They stabilize the wall horizontally. Plates are also used during layout to show where all vertical members of the wall will be placed. The size of a plate will depend upon the stud size used. In general, they match the size of the studs, 2x4 or 2x6. There are 3 types of plates: top, cap, and sole. To add stability to the frame, a cap plate is fastened to the top plate. This plate acts to join walls at corners and to add stability to ceilings. Headers are generally solid or built-up lumber that acts as a load bearer in wall openings. Headers fill in space left between an opening and a top plate. In certain cases, a header is installed with cripples above it running to the top plate. This application is generally reserved for window openings. The size of a header will depend upon the plans, specifications, and codes. The lumber used to create headers ranges in type and size. The 2 types of material used are built-up or solid lumber. The built-up lumber may be glue laminate, veneer, or solid lumber fastened together. The size of the header in the frame is determined by the span of the rough openings, or RO, and number of floors. RO are the places in a wall frame where windows and doors are placed. The site of the rough opening, or RO, is specified in the building plans. Cripples are shortened studs that run between wall frame openings. Generally, the cripples run from the sole plate to the sill, and from a header to the top plate. Cripples add stability to openings, and they provide load-bearing support. Typically, cripples are either 2x4 or 2x6. Trimmers, sometimes called jack studs, are similar to cripples in that they are used as an additional support in wall openings. Trimmers run from the sole plate to the bottom of the header. Their function is to support the header. Like cripples, trimmers are either 2x4 or 2x6. Sills are supports for window openings that run horizontal to the studs in a wall frame. They can be found at the bottom of a window opening. Sills are supported by cripples and are fastened to trimmers. Like cripples and trimmers, typically sills are either 2x4 or 2x6. The sill's length is determined by the size of the RO. Now that you are familiar with the wall framing components, it's time to lay out the wall frame. Before any wall is framed, it's critical that construction craft laborers refer to all plans, specifications, and codes. The construction plans will detail the length, width, and size of all the wall frame members. The plans will also provide detail on where all openings will appear and whether walls are weight-bearing or non-load-bearing. In general, the rough opening is slightly larger than the window or door. The size of rough openings found on plans and specifications can be shown in several ways. With windows, the dimensions of the rough opening may be shown on the plans and specifications, or a window schedule may be used. A window schedule lists the types of windows used in the house construction, as well as the size of the window and the necessary size of the rough opening. The window schedule is a great tool to use when determining the rough opening for a window. Door openings are a bit different from windows. Some doors may have a door schedule for rough openings. If there's not a schedule for the doors, there are a few general rules to follow to determine the RO. The overall height of the door is usually either 6 feet 8 inches or 7 feet. When calculating the height of the door, add 2 inches to the total length to calculate the rough opening size. When calculating the door width, 2 inches is again added. These added lengths may vary, so be sure to check with the plans and specifications of the house, as well as the manufacturer's guidelines for rough opening size. When a wall frame is constructed, it will have a sole plate. However, the sole plate will be cut out at door openings when the wall is raised and fastened. With the sole plate cut out, measure the rough opening from header to sill. When marking the layout of the sole and top plates, it's critical that the center line of the rough opening be marked. The type of wall will determine whether the distance to center is measured from the outside edge of the perpendicular wall or from the end of the top plate. To properly determine the rough opening, identify the exterior doors and windows on the plans. Determine heights and widths for those doors and windows. After reviewing the plans and specifications, it's time to measure and mark where all the framing members of a wall will be located on the top and sole plates. The first thing to consider before laying out the plates is which wall to start with. As a general rule, the first wall to be laid out and framed is the longest exterior wall. This wall will have an effect on the markings and measurements of all the other walls in the frame. These markings will determine the location of the first stud in the longest exterior wall. For walls 16 inches on center, this first stud is generally measured to a distance of 15 1/4 inches. This distance takes into account allowances for sheathing and boards attached to the studs. When measuring for frame members, the top and sole plates will have the same markings, so they can be laid next to each other and marked. When marking the position of the wall framing members, it's important to have a guide to help you remember what is being marked. In general, X marks studs, T marks trimmers, and C marks cripples. When marking the top and sole plates, it's also critical to mark the openings. When marking openings, a construction craft laborer should review the plans and mark the center line of each door and window opening in the wall. Mark trimmer stud positions on the outside of the opening marks, and mark the full-length studs next to the trimmers. Locate and mark any crippled studs in the opening. There are situations where special considerations for wall layout should be taken. For instance, corners and partitions of inside walls need to be planned when laying out the wall frame. When set correctly, a corner strengthens and braces a wall. In most cases, a second stud is placed at the corner of a wall to add support for nailing. Small cuts of studs called blocking may also be used to add nailing support. The blocking is placed at multiple points between both corner studs. Once the layout on the sole plate and top plate is complete, the wall frames can be assembled. After checking the plans and specifications, all the wall frame members can be cut and fastened together. When assembling the walls, the exterior walls should be the first to be created. Construction craft laborers need to measure and cut all wall frame members before they are laid out. Generally, a circular saw or radial arm saw are used to cut the framing members. Many times, full studs are pre-cut to a standard length of 8 feet 1 inch. This is the standard height of most ceilings. Finally, cut the cripples, trimmers, sills, blocking, and headers. Since headers are made of built-up lumber, they will need to be created before the wall is assembled. Remember, the header size and the lumber used will depend upon the number of floors in a building, as well as the rough opening size. Be sure to check your plans and specifications, as well as local, state, and national building codes for the size lumber to be used for headers. Special care should be given to accurate measurements and precise cuts. Once the wall framing members are cut, it's time to assemble the wall. The first step is to lay out the top and sole plates that have the layouts measured and marked for all the framing members. The marked portions of each plate should be facing each other. Place them a short distance beyond the size of the finished full studs. Once the top and sole plates are laid out, the rest of the wall framing members can be fastened. Typically, each of the members will be fastened with 16D nails. If possible, a nail gun should be used to fasten the members. The full-length studs are generally the first member fastened to the top and sole plates. Once the studs are in place, the blocking, trimmers, cripples, sills, and headers are fastened. Next, attach your cap plates. The cap plate is an additional plate added to the top plate. One end of the cap plate will extend out and over the next wall's top plate, while the other end will be cut short, so another wall's cap plate can rest on it. Once all framing members have been fastened, the wall can then be raised. Once the wall is framed, it can be raised, aligned, braced, and plumbed. In most cases, construction craft laborers will raise the wall. But for larger walls, a crane may be needed. In either case, the same basic procedures are followed. In order to raise a wall, blocking may be applied to keep the wall from slipping off the subfloor. A chalk line is marked where the inner part of the sole plate will be located on the subfloor. This will help to align the wall when it is raised. There may also need to be bracing on the wall before it is lifted into position. The studs are notched, and the brace runs diagonally from plate to plate. To raise and anchor a wall frame, start by striking a chalk line for positioning. Square the wall using the diagonal measurement method. If specified on the plans, add sheathing. Tilt the wall upright and into place. Nail through the bottom plate into the floor framework. Brace the wall for plumb. When a wall is raised and set in place, it may need to be adjusted to the correct position. Gentle taps from a large hammer may work, as well as pushing or nudging from the crew raising the wall. Once the wall is in position, temporary bracing may be added to prevent the wall from swaying or falling due to wind or other environmental factors. Usually the bracing is made of 2x4s set diagonally to the frame. With the wall aligned and plumbed, the temporary bracing is nailed into the joists, headers, and the studs. Drive nails 3/4 of the way to hold each brace. After the walls are raised, aligned, braced, and plumbed, the cap plate can be nailed at each outside corner. Once the walls are up, aligned, and supported, you are now ready to begin installing backing and blocking. Backing is a critical framing member needed to help support items hung or fastened to walls. Cabinets, light fixtures, bathtubs, and lavatories all require the extra support that backing provides. Backing is simply a piece of wood that fills in the space between two studs. Backing might be an additional 2x4 or a larger piece of solid lumber. Using the plans as your guide, determine the final placement of a cabinet or fixture. Transfer your measurements to the studs. Cut and measure the blocks to fit between the studs. Now nail your blocks in place at the desired height. Like backing, blocking is used for additional support. Instead of supporting fixtures or cabinets, blocking acts as a support for exterior wall sheathing. Blocking solidifies walls by adding horizontal stabilization and acts as a barrier to a fire's path. First, determine the placement of your blocking as indicated in the plans and specs. Measure the height at which your blocking will be placed. Stagger blocking heights between the studs. Transfer your measurements to the studs. Cut and measure the blocking to fit between the studs. Finally, nail the blocks in place at the desired height. Wall sheathing is the outermost rough layer of a wall frame. It's used as a fastening area for brick or siding. Wall frame sheathing can be made of multiple types of materials. Most often, the materials used for wall sheathing are plywood, fiberboard, gypsum, or rigid insulation. Wall sheathing is similar to subflooring in that the finished wall will be placed over the top of it. Wall frame sheathing comes in a variety of sizes, ranging from 2 feet by 8 feet to 8 feet by 14 feet. One of the most common sizes of wall frame sheathing used is 4 feet by 8 feet. There are also standard thicknesses for wall frame sheathing. Common thicknesses are 1/2 inch to 25-30 seconds. When installing the wall frame sheathing, it's critical that there are no protrusions in openings or beyond corners. Sheathing must be fastened securely. Depending upon the size and thickness of the sheathing, 8D or 10D nails should be used. The nails should be fastened at the studs about 6 to 8 inches apart. Measure and cut the sheathing to fit from the corner edge to the stud center. Nail the first sheet in place. Measure and cut the rough openings as necessary. Install subsequent sheets, maintaining the specified gap between sheets. Measure and cut the final sheet so that it is flush on the outside corner. You may prefer to attach the sheathing prior to the wall being raised. This allows for safer and easier working conditions. Remember that all other facets of residential construction are dependent upon having proper framing. Both wall framing and floor framing are critical elements to the residential structure. Knowing and understanding the framing components, as well as the proper construction methods, makes a construction craft laborer a valuable part of the construction team.